Okay, so we've been working really, really hard. You've given it your best shot. I'm really proud of the effort you've put in the last hour. So here is our question. That's tricky. Yeah, I know. I believe in you though. Don't worry if you don't get it right. I'm not expecting you to get it right. We'll give it a go together though afterwards. Oh my gosh. That's right. You're a genius. Wow. I really need to go and teach year 6. Is it on? You working? Are you there? Hi Year 6, hope you're all well. Welcome to Thursday's lesson. I think it's Thursday's lesson. Before we get onto the lesson though, I would just like to say on behalf of myself, Mr. Kilduff and all of the Year 6 members of our team, a huge thank you to all of you. Your responses to these online lessons and the videos we've been producing have been amazing through all the lovely things that you're saying and the amazing work you're producing. You're all trying so hard and it means a lot to us, so thank you. Keep on sending the amazing learning in, we're loving seeing it and we're all really, really proud of you. Right, on to the lesson. So far this week for our big question of the week, how does the wingspan of a helicopter affect its falling time? We have created a question, we have created a hypothesis, you have conducted your investigation, collected data and presented the data. Today we have 2 things we are going to look at. We are going to analyse our data, see what it tells us, and we're going to write a conclusion about whether or not our hypothesis was correct. We've also got some vocabulary which we're going to look at in the conclusion, but I will explain why when we get to it. The first thing we're going to look at is our analysis. So our analysis is essentially finding out what the data tells us. So I've got 3 steps here that we're going to look at. First of all, when we do our analysis in a minute, we're going to look at the data, look at the graph that you created yesterday, and we're going to see are there any trends in the data. Then we're going to look at what we can interpret from the data. What does the data actually tell us? And finally, if you're looking to stretch yourself, you might want to look at are there any links in the data. We'll talk more about that in a moment. Okay, so we look at the line graph here. I'm using the one that Mr. Kilduff has drawn as opposed to the one that he created on Word yesterday. That's because I find this here. I'm saying here. It's confusing because my laptop's here and it's I'm using this one because for me, I find that easier to read. But if you find the one on Microsoft Word easier to read, then use that. Right, on the little screen now. So here, or here, I don't know where I'm going to put this video yet. Let's say here, you should see Mr. Kilduff's graph that he created, the line graph. By the way, Mr. Kilduff, great use for a ruler. Good job, perfect. You can see his graph there with a little shadow of his phone sticking over there to take a picture. On the left-hand side here, we can see the time of descent in seconds. So each one of those, you've got 0.5 seconds, 1 second. So the lower down on that axis there, what's that axis called? Yes, the Y one, up, Y axis. On that axis, it shows us the time. So the further down that, the quicker it fell. The further up it, the slower it fell. You get the idea. And then on the X-axis, so along the bottom, it's beautifully titled in its lovely neat handwriting there, we have the wing length in centimetres. So this is for both blades combined, what is the length of those blades? So the smallest one we have on there is 6, as we know, and the largest is 14. So now we need to analyse it. Let's get analysing. So the first thing we need to do is analyse the trends in the data, if you remember what was on the whiteboard earlier. We're looking at what trends does this graph show us? Is it kind of like all jaggedy and we can't really read the general trend of what's happening? Or can we read something? Now, looking at this, I think we can see a general trend. Generally, it starts low and goes up. So the general trend in this is that the smaller the wingspan, the quicker the descent time. So the shorter the descent time. Yeah. So if you can see right at the bottom there, it's down very low, and at the top, it's up really high. So the trend here is that the longer the wingspan, the greater the time, the shorter the wingspan, the shorter the time. And actually every time we shorten the wingspan, if you look from right to left here, we started with the largest. Every time we shortened the wingspan, the time fell by quite a bit, especially early on. It slowed down a little bit, between 10 centimetres and 8 centimetres, then dropped quite a lot again there. So generally, the trend is that when we cut the wingspan, it fell quicker. To put it on, we're going to put this in writing in a bit, by the way. We're going to just analyse it first. The second one is, what can I interpret from this? Well, what is it telling us? It is telling us that the shorter the wingspan, the shorter the fall time. We're going to look at why that is in the conclusion in a bit. And the stretch challenge here, so if you are a very mathematical thinker, then this one's for you. I'm not going to go into it now because I think it would take quite a long time to go into, but basically you are looking at, are there any links? So is there an average time it drops per centimetre cut off? Now I can look at this and I can see that actually the times vary. Well, how much do they vary? Between the first, second and third attempt, is there a scale factor that's getting smaller by? I'm not going to go into that because I don't want to give them away the answer. And like I said, it'll take a while, but if you come up with anything, I'll be really, really impressed, and that'll definitely be worthy of a home learning certificate. And we all know they're good. That's our data analysis done. It's quite simple, really. It's just looking at this and analysing what it's telling us. So now that we have analysed our data and we've looked at what it's told us, and we've figured out that the trend was the shorter the wingspan, the shorter the fall time, we need to move on to our conclusion. So for our conclusion, we're going to talk through these and then I'm going to show you how I've written them after that so that you will know how to write it up for your experiment. So again, for our conclusion, there are 3 things I want you to consider. Number 1, using my data analysis, can you determine whether or not your hypothesis was correct? Was it incorrect? How do you know? For us, our hypothesis was that the shorter the wingspan, the greater the fall-in time, meaning that the helicopter fell slower when the wingspan was shorter. Now, using our analysis of our data, we have determined that actually our hypothesis, that's Mr. Kilduff and I's, was in fact incorrect. It wasn't right. And that's okay. That's part of science, finding out whether something is correct or incorrect. So how do we know that? We know that because our test showed that every time we shortened the wingspan, the fall-in time actually reduced every time. So we've actually got very conclusive results there. The second thing we need to look at, this is our stretch. This is if you're really looking to challenge yourself. Do you have any scientific reasoning for this? For what reason do you think your hypothesis was correct or incorrect? Now you may know this, you may not. You may want to go and do further research on it. I've put a link under the video if you want to do some further research into why that may be. Do we have any scientific reasoning as to why we think this has happened? Well, yes we do. So this is where we're going to use our vocabulary of Friston apparently. I meant friction. This is where we're going to look at our vocabulary of friction and air resistance. Friction. What is friction? Pause the video, see if you can figure out what it is. And unpause. Yeah, I'm watching you. I know who you are. You didn't pause it, you just kept watching anyway. So friction is the resistance we get when 2 surfaces meet each other. Here you can see a beautifully drawn diagram of our paper helicopter. Miss Dearlove, I know you're proud of my artwork here. All these very small dots here, these are our air particles. Now particles are in everything. They create the world that we live in. And in the air they are microscopic, so small the human eye can't even see them without help. If your hand around the air, you are moving the air particles. Now our paper helicopter is made of, well, paper, believe it or not. And you can see here that as the paper helicopter comes down, it's meeting the air particles, they're being pushed up against it. And the friction between the air particles that are being squashed and pushed up against the paper and the motion of the paper coming down onto them, that's creating friction. And we call this type of friction air resistance. So as you can see here with my longer wings, there's quite a lot of air resistance there. However, if I shorten the wings, you see that actually the helicopter is coming up against less air resistance. Therefore it's going to fall quicker because there is less friction slowing its descent. Again, if I made the wings a lot bigger, there will be a greater amount of air resistance because there is more friction created between the particles in the air and the paper helicopter itself. Science. So there's our stretch activity. We've talked about that. We know what our vocabulary means. So if you want to do this, make sure you are including this vocabulary in your conclusion. And finally, is one of the most important things about science. If you were to do this investigation again, what would you change? Real science is about constantly trying something and improving it, trying something and improve it. If you think they made computers or vaccinations or anything the first time around, you are wrong. It is often years and years and years of testing, investigating, changing, investigating again and again and again and again. And we need to think about, if we were to improve this investigation, what would you change? Well, I had a thought when we talked about this, about the air resistance. The greater the wingspan, the greater the amount of time of the descent. I want to test that. So for me, I would actually like to do it again, but have an even bigger range of wingspan. I'm talking like, I want to have wings like 1 meter long, if that's possible. I don't have paper that's 1 meter long. Maybe I could find a way to do it. I want to see if that proves my thinking. You may want to change the material of the paper. Different helicopters, all of the same wingspan, but some made of card, some made of plastic, some made of paper. Which one falls the slowest out of them? You may want to change the weight of the helicopter. Again, keep the wingspan the same, change the weight of it by adding paper clips to it. Does that affect the fall time? The key thing is here, what one thing would you change? Because remember, when we do an investigation, we have our independent variable, we change one thing. So what one thing would you change? Right, let's go and have a look at the write-up that I have done, and you can see how to put this into a paragraph in your conclusion. Okay, so as you can see here, I've written my conclusion. I'm going to read it to you, but you pretty much heard me just talking about it, so I won't go into too much detail. So my first point, I've said, according to the results I've gathered and analysed, my hypothesis of the shorter the wingspan is, the longer the paper helicopter will stay in the air was incorrect. The results showed that the shorter the wingspan, the shorter the falling time was, meaning that the helicopter fell quicker. So I haven't just said I was wrong. I've said, no, I was incorrect. This is what my hypothesis was, and it was incorrect. And then I've used the data, and I said, this is the trend the data showed. Then, because I really wanted to stretch myself, I looked at some scientific thinking there. And I put that in red just so you know that's a stretch. That is if you want to push yourself above and beyond. I said, I believe this is because the greater the wingspan, the more air resistance is created upon the descent, as there is a greater surface area on the helicopter blades for the air particles to rub against and create friction. The data I have gathered support this theory. So I basically said, this is what I'm thinking, this is what I think the scientific backing is of it, and actually my data does support this thinking. However, I may want to go and test that further. And then finally, I've looked at what I'd change. I said, if I were subjunctive form, cheeky. If I were to conduct this investigation again, I would collect a greater range of results from larger wingspans to further explore my air resistance theory. So actually, that bit I've put in red, I'd like to explore it more. I'd like to go and do it with an even bigger helicopter. If I could, I'd make one as big as me. I'll be really impressed if you can do that, by the way. I wonder if it would hold your weight. No, don't go on a tangent, Mr. Jobby. You nearly finished this lesson. I've also said, on a separate investigation, I would also like to look at whether the weight of the helicopter had an impact on the fall time in a separate investigation, because I don't want to change two things at the same time, because then it will not give me the results that I want. So let's just check we've done everything we need to today. We have analysed our data, the information we've collected, and we've looked at the trends, and we've used it to help answer whether or not our hypothesis was correct or incorrect in our conclusion, in which we've gone into some scientific reasoning and we thought about what we would change again, and we've written it all up. By now you should have a whole write-up of everything we've been over this week, and that is we want you to send to us. Please also send videos of you conducting the investigation, pictures of you doing anything like that, and if you came across anything you didn't expect, what didn't you expect, what surprised you? Thank you again for all of your amazing hard work. Tomorrow you've got Mr. Kilduff, who's going to be doing this by changing one thing with you, and you'll be seeing me real soon. See you later. Bye. 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 See ya. Yeah. No. Bye. Bye.